in the fight against COVID-19 pandemic. And I'm glad to report that Dr. Andre Kagas is actually one of the a very renowned biomedical engineer that is very up and doing in this area of research. And we are extremely glad to have Dr. Andre here with us, and he's going to share with Nigerian scientists the issue of open access initiative and how we can leverage on it to pursue so many things. In fact, not necessarily COVID-19 pandemic. So, Dr. Andre, thank you so much for accepting our invitation, and we look forward to hear a lot of things from you. The same thing applies to Dr. Rehan Folarin. The concept of 3D printing is also something very fascinating, and is also an expert in 3D printing. And I'm trust that we are going to listen, hear a lot and learn a lot as to how we also apply 3D printing in the fight against COVID-19 specifically, and also in our respective on our various endeavors. To Dr. Kaisan, Dr. Kaisan is someone that had someone that was very Dr. Kaisan was someone that was highly publicized at the peak of the COVID-19 pandemic, because he was also one of those that were able to use local content to develop incubators, not incubators, sorry, to develop I think sanitizers, wash sanitizers and stuff like that. And we are glad that he's a member of the academy, in fact, an executive member of the academy, and he's also here to talk to us on his experiences. So to all the speakers, I thank you so much on behalf of the academy for taking time to be with us. And to the participants, I also welcome all of you, and I hope we are going to have a very robust presentation. Like what Murtala said, please feel free at any point. We can raise question, ask question, raise question, so that we learn. Like I said, for this specific presentation, we can go beyond even learning with respect to COVID-19. We can look at the issues beyond COVID-19, how we can apply open source initiative, how we can apply 3D printing in our respective workplaces and professions. So thank you to all the speakers, to participants. I'm sure we are going to learn a lot. And finally, permit me to also thank the granting body, the COVID-19 Rapid Grant Fund, who have funded a series of webinars, who have funded the project generally. We are always grateful to them. So thank you so much, and I'm sure we are going to have a very rewarding webinar today. Thank you.
Thank you also very much, Mr. President. Without much ado, I'm going to introduce Dr. Andre Maya. And Dr. Andre works at the Department of Neurosciences in the University of Sussex, UK. He's a neuroscientist by training, PhD from the University of Tübingen in Germany. Passionate about open science, open source hardware, and how they can be used to improve research and education quality around the world. His career is dedicated to developing affordable, cutting-edge research equipment that have built designs and instructions freely available, so that everyone can copy, learn, and improve their own research tools. He also organizes courses and workshops so that others can also create their own tools and find solutions to their scientific questions. He started Open Neuroscience, a central repository showcasing open source projects related to neurosciences, and volunteers at Trained in Africa as open source advisor and organizer of workshops. Most recently, he has been involved with BioRTC as part of the full faculty. Dr. Andre, I welcome you very much, and you have the floor for your presentation.
Thank you, Dr. Murtala. It is a pleasure being here. Thank you all of you for coming. I hope that this sound in the background is not too disturbing. We're having renovations in the building that actually started today. Let me just share my screen. Actually, sorry, just a second. This is wrong. And today I'm going to be talking, as you saw the title of the presentation, it's all about using open source tools, and the talk of the presentation, and this I discussed extensively with Dr. Murtala, and we agreed initially to have this as a prompt response in resource limited settings. And then, as you heard from me, and I'm actually using open source initiatives to build things at the university here and in the different places where I worked before. And so I decided that this is actually not super appropriate, because what I'm trying to convey today is that open source initiatives should be used for research and education and innovation everywhere, and not just in resource limited settings. Of course, we can use them as well in those settings, but this is one of the big points, is that using open source tools, they can be used anywhere by everyone, right? Everywhere by everyone, basically. This is not limited then to in a limited resource setting or in a place where you have a lot of funds and so on. Dr. Murtala already introduced me. I can share the slides with you later if you want some of this material. So there are some links here. But basically, all of these different things that I do are all made together by this idea of open source and open hardware. I always like to start these talks talking about this very, very known instrument, which is a microscope, and it's used by many, many researchers in many different fields. And even if you're not a researcher, you know what this is, right? Like you've seen in movies, you know what it does, right? But what you might not know is that this is super expensive. So this microscope that you see here, it costs about 10,000 pounds for the basic model. And so there is a very high cost. There are very few distributors. They're mostly in the global north. It's built with a very few types of labs in mind. So you need to be in a place where there is a certain range of temperature, a certain humidity, a constant power supply, right? And this is quite heavy, for instance, so you could not take it to the field to do field research, which is the case for some researchers. Also, there are no designs available for this. If you need to repair it, modify, you depend on the company. And as we've seen with COVID, the supply chains around the world are really, really fragile. So as soon as there is some problem, I know that this doesn't happen every day, but as soon as there is something like a pandemic, like we're basically shut to the ground, things cannot move in big distances, they don't get anywhere, right? And also because this is super expensive, there are no manuals, you won't be changing this to your exact needs. Right, so let's say I need to change the light source of this because I want something a little bit different. I won't be doing that. Even in the case of the light source, it might actually have just broken, and you need to replace it with a new one. You need now to wait for the company to send you. This thing will get stuck in customs. I mean, you living in Nigeria know this better than I do. I had the same experience while I was living in Brazil, where I come from. Where it's really a nightmare to get imported things for research and education or whatever it is, right? And so then I like to pose these questions. What if a solution for this would be the question, do we have the technology, and has technology evolved enough that we could make new designs for a microscope and actually make it in a way that we could produce it locally, right? And the other question is, what if, once we have these designs, we could just freely share them all over the internet as digital files so that people can copy the designs and make it themselves locally and even make contributions and improve our own designs, right? And so this is here, what you're seeing here is a 3D printer. And I like to put this here because this is the perfect example for these two questions that I just asked, right? So 3D printing technology is actually old. It's from the 80s, but it had a big patent on it. And so nobody could modify and improve without paying the original company a lot of royalties, right? But the patents expired in 2009, which meant anybody now can take a 3D printer, take it apart, make modifications, change, and improve them. And so this is what started happening in 2007 at the University of Bath, which is close to us here at the University of Sussex, where one of the researchers there made a 3D printer from scratch in a new design and shared those designs online. And so a community started building from people contributing and making changes. And this model that you see here, it's kind of one of the most well-known models for 3D printers. There are many, many available. Unfortunately, due to time, I cannot go into the details. But what is important here is that just in 2018 alone, 3D printing became a $14 billion market in the US alone, which was previously almost non-existent. It was relegated to one company that detained all the patents for this, right? And most importantly, now these printers are quite cheap. So I recently visited Yobe State University, the BioRTC, and we brought printers that we bought for $300, $400, right? And you can now get them at AliExpress as well. And so we built the printer there. Actually, Dr. Murtala and our colleagues from the computer science department in Yobe State University built the printer themselves and started printing things and building things for the lab there directly. So all of this, what I'm saying, this idea of sharing digital files so that other people can copy and change and modify and collaborate online and using local technologies for local production, all of this falls under this umbrella of open source, which is something we've always been doing as humans, right? So we share recipes, we share music, we share a lot of things. And open source is just a way where you have a certain set of rules, let's say, or a certain set of guidelines where people can share their designs in a manner that everybody else will understand, and that the authorship is respected, and so that people know who built the original one, who made the derivative, who made improvements, and so on. So even the design for this presentation is open source, and because I don't know how to make designs and layouts for slides, I just went into this website, which is pointed by the big red arrow, and people just put this online and allowed me to use as long as I put the credit, as you see here, where does it come from? So going back to microscopes, open source microscopes, right? Because we're talking about open source. What you're seeing here are 4 different types of microscopes. Today, we're going to focus on the third one from the left, the yellow one. But the nice thing about this is that this is one of the first advantages of open source. There are many different types of solution for the same problem because locally people come up with different solutions, right? And so I wanted to highlight this yellow microscope because it was also published in 2016. It has an excellent image quality, and it's made of 3D printed components and off-the-shelf electronics, and it's very, very well documented, to the point where they now have a big community around them that are like replicating and building. And so this one is something that I printed actually this week, because we're going to build some of this for our labs here as well, for the teaching labs, right? So, and this is now, the same model is being built at BioRTC, at Yobe State, also with the idea that they can use for the research, but also for education. One simple example of what this microscope can do, and this is an image from one of their papers, I can share the links as well later, but what you can see here is just image. So on the left side, you can see basically the optics behind this microscope, and they're much simpler than your traditional microscope. You have an LED at the top, then a small lens that collimates the light or makes the light uniform to reach the sample. Then you have the microscope objective. And here they're buying, and we bought as well, microscope objectives from AliExpress for like $40 each. And they work to do these images that you see on the right side. Then you have another lens that helps focus the image from the objective into a webcam, basically, right? And so what you're seeing here on the right side is blood smear, where all the purple circles are red blood cells. And on the smaller part, on the inset, on the bottom right, the darker purple thing is a malaria parasite, right? So basically, you take a microscope that takes you a couple of hours to print the main body, about 10 hours to print the main body, another $200 worth of parts, and you have a tool that you could be using to detect malaria. And because the whole thing costs about $300, if you compare to the price of 10,000 pounds or $10,000 of the microscope I originally mentioned, you could build 10 of these, still save money, and be able to do like a massive parallel system of 10 microscopes working at the same time to collect data, to do malaria detection, and so on. So this is just one example. Because of the limited time, I just wanted to give a very brief overview and one example so that we can have an active discussion later of what you can do with open source hardware. This is one example. These are places where OpenFlexure has been deployed. So the purple places is where people have built OpenFlexure microscopes. So you can see even in Antarctica, this has been built and used for research, where you normally wouldn't, like you would have a really hard time bringing one of these heavy microscopes there, right? So as you can see, it has been deployed in places in Africa as well. We're still like coming to the, like I think in BioRTC, we're coming close to building the first one in Nigeria, as far as we know. Maybe somebody else has built, we just don't know about it, right? And so we can add Nigeria to that map as well. And so this is one example of what you can do with open source hardware. And so I'm pretty sure Dr. Hoya and Dr. Mohammed are going to talk about other opportunities in open hardware. And so therefore, I would like to move into another aspect of open with the time that I have to show you like how big this idea is. And so what I'm showing you here is changing paces a little bit, showing you the cost of insulin from 2009 and the current price in 2019. And what you can see is that this went many times over above the original price and many times over above inflation. And this is the cost for insulin in the US, right? And so a really wealthy country. Are people just seeing my screen now?
Yes,
hello?
you can see. Yeah,
you've been seeing this the whole time though?
Yes.
Oh, okay, fine. Just because I got a, never mind. Sorry for that. So the point of this image is to say the prices of insulin, because they're only produced by these 4 companies that are normally just produced by these 4 companies that are listed here, has gone super high, way above inflation over these 10 years, to the point where people in the US are unable to buy insulin, or they have been actually skipping doses and trying to be really sparing with the insulin that they use, to the point where like they're damaging their own health, but because they cannot afford it, right? And so, and I also can share all of these links to this information, but basically a group of people decided that they're going to build the tools and the protocols to actually produce insulin themselves. As you might know, insulin is nowadays produced with genetically modified bacteria. So in principle, it's not a very, I mean, of course you need biology training and everything, but it's in principle technologically possible to do this, not in a very high-tech laboratory. And so they set up a non-profit foundation, the Open Insulin Project, where there is a distributed network of people developing the molecular biology protocols to produce insulin, the hardware. Some people are working on how to regulate and certify those protocols so that you know that if you follow them, this is health and safety checked and all proper. And the estimated cost per vial would be $6.1 US, which is much, much cheaper than what is commercially available nowadays. And most importantly, because people are sharing all these protocols, you could produce this anywhere in the world, right? And so you go back to this idea of local production. And so in the case, again, of a pandemic, you wouldn't rely on importing things from very like far away. There is an opinion in a paper, like an opinion paper published, which I can also share the links to this afterwards, that talks more about this project for those of you who might be interested in more details. One last example is the GLIA X project, which is from a Palestinian Canadian doctor that works in Palestine and couldn't get stethoscopes brought into Palestine. And also their costs were quite high for them to actually buy them in bulk. So they worked together with engineers and other people to come up with this model, which is a 3D printed stethoscope with some rubber tubing and some other parts that you can build for about $10. This is all published online and peer-reviewed in an academic paper. And what they show is that this actually performs, and what you can see here on the line, like everything that is closer to the to zero here on the y-axis is better. And so the black line is the Littman Cardiology 3, which is a state-of-the-art stethoscope. for medical doctors, and the gray one is the 3D printed one. So you can see for lower sound frequencies, the gray one actually works a little bit better. I mean, the differences are not significant, but the point here is that you have something that costs $10 to produce locally once you have a 3D printer. And it performs as well as the commercially top of the line available stethoscope, right? And this group is actually going now for otoscopes and other medical devices so that anyone can build them locally. There are many projects coming online, and there are many hardware projects being disseminated and shared online. These are just a couple of examples. Here on the bottom, on the top left, you can see on the palm of the hand, that's an atomic force microscope. So you can actually see things at an atomic level of precision. Then here at the bottom, the third one from the left is a computer cluster based on Raspberry Pis. You have devices like something to detect your heartbeat and the shape of your heart rate, things to hold Eppendorf tubes and so on. So there are many examples. But what I think it's interesting is that this is work that, like, this is something we're working on that is not published yet. The speed on how you're getting more and more papers being published describing open source hardware, and this is what you're seeing on this image here. So we basically used open source hardware as a search term on PubMed, which is the database for medical and biomedical research papers, and classify them over the years. And what you can see here on the y-axis is that there are only, of course, a very small fraction of all papers in PubMed. But then what is interesting is that from 99, or let's say from the 2000s to today, what you have is an acceleration on how many of these papers are published each year, meaning there are more and more designs of open source hardware for science, for health coming out there. So there are loads of things that people could just like read the paper, go to the repository that has all the information for the design files, and replicate things locally. With that, I would like to say thanks. I hope I stayed in time, and I wanted to keep it short and give it like a very high overview, just to give people an idea, because I'm pretty sure my colleagues are also going to go into more details about this. Yeah, and I guess you can always contact me on Twitter or via email. And I guess we'll save questions for the end of the session, right?
Yeah, thank you so much. I think the participant will agree with me that learning this thing has opened up a whole new area in their mind, where now you don't have to wait. Because when I came back from my PhD, one of the major things that I thought would be an obstacle of getting a laboratory to start with. But then when I met you and you started telling me that, no, you don't have to wait, because these things, you can build them with minimal cost. Then I went online, then I found that even centrifuge, somebody just bought a blender and changed it, modified, and it becomes a centrifuge that works and separates antibodies. And that was what I thought was going to be one of the major obstacles that I'm going to face. But so the participant, this is one of the things that your take home is that whatever you think is going to be an obstacle, look online, open source, and see if somebody has thought about it. If nobody has thought about it and you think it's useful, see how you can contact experts in the area, and you can build something that is going to cut the prices into maybe 10 times lower. Thank you so much, Andre. Now I'm going to introduce Dr. Kaisan. Then he's going to give us his presentation for 2 minutes. I believe you can see my screen now. Dr. Kaisan Muhammad Usman is a senior lecturer at the Department of Mechanical Engineering, ABU Zaria, and the Deputy Director and Head of Technical Services, Department of the National Agency for Science and Engineering Infrastructure, NICENI, in Abuja. He obtained his B Engineering for Bachelor's of Engineering, Master's, and PhD in Mechanical Engineering from Audible University, Zaria. He has published about 65 journal articles. He has 35 conference proceedings, 10 book chapters, and he has 4 patents. He's a foreign registered engineer and a fellow Solar Energy Society of Nigeria and African Society for Engineering Management. He's a member of many professional bodies such as National Society for Engineers, International Association for Engineers, and World Society for Sustainable Energy Technologies, Association of Inventors, Association of Nigerian Inventors, and the Nigerian Young Academy. This is there are many, many more that I don't have to list here. Dr. Kaisan, you are welcome, and now you can begin to share your screen and give us your presentation for 15 minutes.
Thank you. Brief introduction, and I hope I will be able to do justice to the based on what you just introduced. People will think is a big scholar, while I'm just learning and trying to be like you. Let me start by
It's like we have lost Dr. Kaisan, right?
No, he's sharing the screen. I think we can see the screen now.
Is the screen ready now?
Yeah.
Yes.
Yeah, thank you so much once again, and yet again. Nigerians towards the development of scientific.
Dr. Kaisan, I advise maybe you can switch off your video. It's going to be better, probably.
Okay, let me see.
It should be better.
Is it okay?
Yeah, we can hear you.
We can hear you.
No, you can hear me. Can I?
You can continue, sir.
I said the topic is contribution of Nigerians towards the development of science and engineering infrastructure in response to COVID-19 pandemic. It's presented by Engineer Dr. Kaisan Muhammad Usman. It's an NYA webinar today, 15th September 2022. And this is the outline of my presentation. I have introduction, challenges facing science and engineering in Nigeria, tips for reforming scientific and engineering practice, justification, then Nigerian content in the Development Act, Nigerian scientists and engineers to COVID-19, and conclusion. Science is the search for truth on natural phenomena. Studies following a well-defined procedures. These procedures can be definition, observation, experimentation, gathering and statistical analysis of data, formation of theories. Technology is the practical application of scientific discoveries to solve the global problems. In between science and technology, we have that is engineering, which is a combination of science and technology to design, analyze, model, optimize, simulate, construct, fabricate, control, forecast, manage, build, reposition, maintain and sustain engines, machines, systems, structures, processes, materials, components, and so on and so forth. During the pandemic era, the Nigerian government has made an open statement that about $330 million is required for the procurement of medical equipment as well as PPEs to make sure that the medical experts as well as the population of Nigeria is taken care of. That has challenged so many scientists and engineers to see what they can contribute towards solving the pandemic problem. But unfortunately, there are so many challenges facing scientific and engineering practice in the country. One of them is poor funding Another one is lack of functional policy framework. There is inadequate or functional workshop or laboratories and other facilities. There is unstable engineering roadmap. The curricula are very poor, not updated in most cases to go with the global best practices. There is decay in the educational infrastructure, and there is non-full implementation of the educational budgets. Although I am with a federal government agency right now, but I will have to admit that our researchers are poorly funded, and the government has to be up and doing, and we need to have political will to ensure that our research facilities are up to date while the researchers don't have the paucity of funds in order to progress. We should have tried as much to have compliance to standardization and precision, ensure value chain management, then academia industry collaboration, engage in continuing professional development, improve quality of design, reduce time spent on non-scientific and non-engineering activities, and also provide funding for micro, small and medium scale industries, if at all we want to blend globally and also respond positively in terms of any upsurge of any pandemic. But it is in that era, despite the fact that the Nigerian Content Development Act has provided the need for Nigerian scientists and engineers to be involved and trained in any engineering or scientific project within the country, especially in the oil and gas sector. But this is applicable to any other part of discovery or innovation that has to do with reverse engineering or technology transfer. But despite the hardships, people took it seriously upon themselves that they need to do something to make sure that in case all the borders are locked, Nigeria can still survive the COVID pandemic. That was why people worked with their little available resources and came up with beautiful innovations. And to that extent, Nigeria had recorded so many science and engineering infrastructures with beautiful innovations and patentable ideas during the COVID era. I'm going to highlight a few of those innovations developed by my employer, National Agency for Science and Engineering Infrastructure, and my permanent employer, Ahmadu Bello University, Zaria, our neighbors, the Air Force Institute of Technology, other universities and polytechnics within Nigeria like ATBU and Federal University Nekede. These are the few ones I was able to contact within the time being and get some of their records. There are so many other ones that are beyond the presentation of this webinar. But let's take this one by one and see what contribution they have made during the COVID pandemic. The National Agency for Science and Engineering Infrastructure, NYSENI, has a mandate to specifically look into the area of capital goods, research, production, and reverse engineering with respect to 6 broad areas. These areas are engineering materials, plastic, glass, ceramics, polymer, electronics, and nanotechnology, industrial and analytic chemical materials, including industrial gases, scientific equipment and components for education, research, and industry, engineering accessories, power equipment, and mechanical engineering tools. During the COVID pandemic, NYSENI has contributed in the areas of disinfection chamber, which has about 450 persons per hour, which can disinfect up to 450 persons per hour. This is an O shape. There are other disinfection chambers developed by NYSENI. This is a U shape, which can also disinfect about 450 persons in 1 hour, so that if there is traffic, you can now arrange them either in series or in parallel, depending on the kind of disinfectants you want to use to make sure that whoever is passing or is coming into a specific building is safe and cured of any pandemic. The other one, also, which disinfects up to 600 persons per hour, was developed by the National Agency for Science and Engineering Infrastructure. Accordingly, there are some disinfecting sprayers mounted on vehicles, existing vehicles, to make sure that there is disinfection of the full environment, our streets, hospitals, colleges, universities, market areas, and so on. And this one can cover up to 1.5 kilometers before you refill the tank. This is a sketch because we could not get a clearer picture due to paucity of time of another tanker that is improvised to disinfect the environment, which can move up to 2 kilometers before the refill. And for local areas, a tricycle was improvised like a canopy to carry out the disinfection, which covers up to 700 meters, that is 0.7 kilometers of environmental disinfection. There are some other hand-used disinfectants developed by the agency, which about 700 persons can use, which when used for disinfection by individuals, it can cover up to 700 persons per hour. Then the hand washing tank for sanitizing before you enter into your office or any public place. It uses pedal, it's operated by pedal, so that once you match it, the water and sanitizer will come. You wash with soap, water, then the sanitizer is applied. They also produce intensive care ventilator for respiratory aid, which also assists our patients in the hospital. There is another electropneumatic ventilator, different design from the former, developed by the agency. Then this is a 3D printed nose mask or face mask for self-protection by individuals during the pandemic era. Ahmadu Bello University, also I was lucky to be part of the team, and I led the team of 10 engineers who developed ventilator and hand sanitizing machine. And you can see from the clip,
Professor, while the clip is going on, I think I need to remind you the time. You have 2 minutes. Dr. Kwezan?
hello?
Kwezan? Yeah, I
Yeah,
need to remind you that they have 2 minutes roughly.
2 minutes? Okay, let me rush through. This is a center developed in Ahmadu Bello University for personal protection equipment in the Department of Polymer and Textile Industries. They produce face masks and overall cover for medical personnel and so on. And the Department of Communications Engineering have developed hand sanitizing machine and oximeter and so on. One of our students in the university and department asked me, and my mentee, Usman, under his private company, Dasman, has developed intensive care ventilator. The Federal University in Ecuador fabricated a manually operated hand washing and drying machine to help maintain hygiene. This is ATBU Bauchi, smart ventilator for detection and monitoring of respiratory problem. And this is how the ventilator work in a kind of, what do you call it? Is a blockchain of how it works. The aerosol box developed by ATBU and disinfection chamber 2 by ATBU Bauchi. Then the Nigerian Air Force 2 developed their own intensive care ventilator in collaboration with Ahmadu Bello University, Zaria. Now, there are so many fabrications, innovations that lead to patent issuance by the Federal Ministry of Industry, Trade and Investment during the COVID era by Nigerian scientists and engineers. Although in conclusion, we say engineering is a hybrid profession between science, technology, and mathematics, and engineering is full of challenges in Nigeria in terms of policy, funding, facilities, workshops, roadmaps, curriculum, and unstable power supply. But despite that, Nigerian scientists and engineers have contributed immensely towards curbing the COVID-19 pandemic. But most of these are in prototype and have not been commercialized for rapid response against future outbreak of similar pandemic. The major issue we have is commercialization of the technologies because of paucity of funds. So we need to see how we can fund our prototypes to be commercialized and mass produced and keep them in case of rapid response for any future attack. The main area of contributions has to do with intensive care ventilator, whose supply was scarce at the peak of the pandemic, meaning that the country was prepared to stand alone and face the COVID in terms of science and engineering infrastructure, if at all we were able to take our innovations to commercial level in collaboration with micro, small, and medium-scale industries. Academia and industries have played a vital role in terms of research and innovation. NASENI, Nigerian Air Force, ABU, ATBU, NDA, who were not able to get their materials, Pedfoli, Nekede, and Dasman Tech, among others, have made Nigeria proud and gave hope to the country during the pandemic era. To transform the engineering practice, we need to improve design quality, standardization, precision, value chain, uninterrupted power supply, funding of micro, small, and medium-scale industries or enterprises, then dissemination of research findings, engineering management time, and I appreciate by the Nigerian Academy to share this at this precious time. Thank you.
Okay. Thank you so much, Dr. Kaisan, for this your insightful. We can see that I think whoever was following the news during the pandemic already knew about your work in the production of ventilators during the. And I think now we may take it for granted, but during the pandemic, it was a serious issue because we didn't know what the pandemic was going to do. Supposing that it was doing something that happened, say, in Spain or in Italy, it would have been a disaster. So I think this is something that we all need to wake up and see that, I don't know how to wake up because there's been the onus on the government to fund the research on and the development or to commercialize and mass produce this equipment so that in the future, if there is any similar, which we're not hoping, but it's something that we should be prepared to face, that we need to have these things on ground. Okay, our next speaker, Dr. Rehan Folarin from Olabisi Onabanjo University, is a lecturer in anatomical sciences, the Department of Anatomy, where he is the head of neurophytotherapy research unit in a bid to identify therapeutic alternatives to the detrimental antipsychotics and neuropalliatives currently obtainable. Rohan is also a 3D printing expert and an advocate of free and open science hardware, skills harnessed by his research group to fabricate and distribute personal protective equipment to neighboring communities in the wake of COVID-19 as a contribution towards flattening the curve. He attended the University of Ilorin for his bachelor's and master's degree in anatomy and the University of Ibadan for his doctorate degree in neurobiology. He's a beneficiary of numerous grants, including from the Schizophrenia International Research Society, Alzheimer's Association, International Brain Research Organization, Teacher Research in Natural Sciences and Development in Africa, which is TREND, and International Society of Neurochemistry. He is also a member of several international and local professional bodies. He's currently the Peers African Lead in the International Society to Advance Alzheimer's Research and Treatment. Dr. Rehan was awarded Fellowship of the African Science Literacy Network. You are welcome, Dr. Rehan, and you have 15 minutes to speak with us, please.
Thank you very much. Am I able to share my screen now?
Yes, and okay, you can begin.
Okay. I hope, can you confirm seeing my slides?
Yes, you can see.
All right, so thank you very much, Dr. Murtala, for the kind introduction. It's really a pleasure being here. A lot of appreciation to the Nigerian Young Academy for this invitation to Rub Minds, and we've been told to speak a little bit as regards 3D printing as a tool for rapid response to pandemics. So this is a paradigm that is quite suitable to be referred to as a way of thinking out of the box, if you allow. So unlike Dr. Muhammad, who just concluded his presentation, I am more from the biomedical background. I originally trained as an anatomist, and by virtue of research, I concentrate on biopsychiatry and neuroregeneration using mice and Drosophila models, and taking me through the conduct of various phytotherapeutic investigations. So you may be wondering, how did we cross paths with 3D printing and the concept? So that's to the fact that it is a technology, a tool that has come to stay as a way of thinking out of the box, like I said earlier, and a way to innovate and fabricate or get alternatives to hardwares or laboratory hardwares that previously would be considered unreachable. So free and open source labware therefore became one of my interests that I actively pursue as well. So today's story is reminding us of something that came to visit us recently and is still very much around, as we all are aware, and that's the COVID-19 challenge, which is what has reminded us all to talk about pandemics from one moment or the other. So it's a challenge that has been attributed to a zoonotic origin, and it came with numerous challenges of its own, particularly to healthcare system, such that it became very challenging to get personal protective equipment, to such extent that the World Health Organization recorded that on the average of 89 million masks are expended periodically, 30 million gowns, and many more of PPEs that kept running out of stock or availability. So that presented us with an obvious need to create PPEs against COVID-19 for the general community, as well as for patients, as well as whether the symptomatic or the asymptomatic carriers. And also it's something that is highly needed by health workers at their various stages of roll call. So the problem became further compounded by the fact that all over the world, where African countries would naturally think of getting help, became a challenge for them as well to sustain the availability of these PPEs amidst themselves. So it was really a global resource shortage to such extent that the World Health Organization called for a 40% raise in the PPE production across the world. So we have always been faced with this challenge of we as African communities coming out gradually of this perpetual dependence on the global north or of aid, foreign aid generally. So for as long as the African communities or the low-income communities continue to express their challenge and also wish to attain the status that the global north have attained today, one very important connection there will have been money. That is one thing that would have helped to turn around the society, the African society, into what we experience in the global north. But without that, we know the money is not easily come by, right? So it reminds us of what Rutherford said, that we haven't got the money, and so we'll have to think. And this is a general concept which Dr. Andre had given us some introduction about. And the concept of open labware, generally, as well as 3D printing, being a subset of that, is to think out of the box and then reduce the basic concept of every complex laboratory equipment to the basic mechanism of its action, what it's meant to serve. So we can see an incubator here. We try to understand how these things work and to know that the main thing it does is incubation, right? And a centrifuge over there is essentially meant to spin, to give us some spinning movement to help us separate some particles. We have a thermocycler there, which is basically hinged upon the amount of temperature it's able to deliver, to our reagent. And then we have an electrophoresis apparatus there, which essentially delivers some charges. So it gives us this responsibility to think out of the box and try to reproduce these things as much as possible, all right? Such that when you get into a typical workstation, you can always think of what could give similar effects to all of what these things, these bigger equipment have come by. So that's a way to summarize the concept of open labware, a subset of which is 3D printing. And as to what we've been told to talk about today, a 3D printer essentially, like we see here, is 3D printing is otherwise referred to as additive manufacturing, because it's more like you building something, it's successive layers of substances over previous layers. So it's referred to as additive manufacturing, and it's been around for quite a while now, and it's underwent a lot of modifications over the ages down to what we currently have now, such that we have diverse printers and different types of filaments, right? So here is a typical 3D printer that runs on the filament deposition model system, such that you have your filament giving some deposition action, such that it builds the object of interest from the scratch and continues to deposit the filament over and over, until you have the exact structure that you want. So here on the right is the 3D printer that we use in our lab, with which we were able to make little contributions towards the pandemic, the flattening of the curve of the pandemic. 3D printing is something that makes you quite relevant to a number of fields, because there is hardly anywhere that you do not need the intervention of these things. I mean, where you do not need to fabricate some things as ways of alternative. So while it applies so well to some fun things, as we can see on the screen, it's also very relevant to research. So we have a good number of items here that are 3D printed. Here is a typical centrifuge, the little one. that is 3D printed. Here are micropipettes that are all 3D printed. So we followed this challenge of acute shortage of protective wears for medical personnel, and especially the encouragement by WHO for there to be an increase in the local production of these things. So we hinged at the beginning of the pandemic. If you notice the date of this publication, it came out as a preprint. We have Dr. Andre here with us in this presentation. So here was a preprint that he led at the beginning of 2020. Then March, that was quite at the beginning of the pandemic when it broke out. And here a number of suggestions were given towards harnessing free and open source hardware. And we hinged on some of these to make this project possible. And we concentrated mainly upon on the making of face shields and nose masks. All right, so a common denominator to all things we see on the screen here are the fact that one component of them or another was actually 3D printed following the open source designs, such that most of these things are free for you to get on the internet. You just need a typical printer. So we got motivated by the fact that everyone with a 3D printer can help, because we had one. And then the source of the designs are open source, and they are easily accessible. And there are easily accessible and inexpensive materials that are simply required to augment these things and make a full product. So as a community, we understood that we could help thousands of people in need. Here was something that has been reproduced in some parts of the world, like Czech Republic, which has Prusa was a company that had successfully donated over 65,000 shields to medics, thanks to the several 3D printers that they had. And here is the Joseph printer, the owner of the company. And you can see this is typically a printing farm, as it's called. So this is a printing farm. So you see so many printers running simultaneously to make this stockpile of face shield frame. Okay, so we had typically a humble infrastructure. We had a single 3D printer, and we got this running in an office. And there you see the enthusiastic members of the lab, students of the lab, putting together the printer and trying to get it work for the first time after we had it delivered in the lab. And so out of a very big building, you probably need not too much of a space to get all these things working. So we had our sketches, and then we developed our prototypes and went further to build this particular prototype of nose mask and face shield. So 3D printing mechanism simply runs on 3 basic steps. First is that you design your intended model on a computer, and then you save it in a format. We are used to so many formats of files, right? But for 3D printing, usually the STL format is how you prepare your design. So you export it as an STL file, and then you get to slice this STL file into G codes, such that each material is able to be recognized by the printer as successive layers. So you can see that this typical model has been broken down into layers. So it's going to be seen as slices by the printer in order to carry on its printing action. And then eventually you have the printer executing the G code available, out there in subsequent meetings. But suffice to say that we simply needed to print this this frame, right? To print the frame, and then we added these other materials which we could get easily around. And we kept in mind the safety precautions because we're at the heat of a pandemic. so as not to, compound the problem that's already on ground. So we handle them with so much care that, acting as though you yourself were infected, that's how careful we try to be in managing this, in handling these materials. And then we also hinge on feedbacks. So these are typical face masks that were built in the lab. That's how they actually are. And so you see the frame of different colors, depending on the types of filaments we used. And then you see the frame, we added some ribbon tipping around the visor, right? And then it could be supported by elastic bands at the posterior end. So we had them on different varieties. And we also paid attention to the nose mask as well. See them coming as well in different colors with different enablements to make them user-friendly, more skin compatible or skin friendly. So we added some cushions because you don't really want to have a plastic stuck to your, to your skin all along. So we tried to improve the compatibility and the friendliness of this product. And it was one of those things that my university was able to present to the community, as part of the interventions as ways of flattening the curve of the pandemic. And we were able to document some of these activities of ours in a preprint as well as in a publication that came out sometime earlier this year. So yeah, and here we have one of the students in the lab who was trying, let's say, the full kit, right? The face shield as well as the nose mask. So this talk is essentially to create awareness, right? So it's for you to start thinking, depending on what research background, what background you are from, what you probably need some interventions for, what you need some fabrications for. If you start thinking of those things you consider worthy of 3D printing, that are quite useful for you as tools in your research project or in, depending on whatever profession that you are coming from. And how would you like to apply the 3D printing in your research or to whatever profession that you are into? So beyond COVID days, even though COVID is still much around, we just wish that it continues to get better by the day. So there are so many diagnostic interventions that the concept of open hardware, open, free and open source intervention or concept will come in very handy and useful. And these are things that we continue to increase our efforts in making available to the research community, as well as to, it starts by the awareness, raise the awareness, and then we continue to contribute to our quota. Yeah. So, and then we continue to contribute our quota to making these things happen. So here is a typical centrifuge that was also made in the lab, right? It's been assembled and been optimized as well. And in case you're wondering what 3D printing has to offer to you, so it's now up to you to think about what you need. What are your needs? Now you know how it works. So it's good for you to remember that with just €100, you probably could have a lot of intervention. Here is a typical surveillance apparatus with a camera fitted. And it's nice to mention that all of the things you see here were 3D printed, except just the camera that was mounted into the holder. So you have diverse things to think about. A lot of needs are there in our continent. So it also has an entrepreneurship component that we actually can make use of. So it's really time for the African youth especially to wear our thinking caps in order to bail out our country. So I finish on this note that in addition to education that was suggested by Mandela as something that is very important to change our world, we need to be ready to help ourselves in a lot of ways. This way we can stop being over-dependent, and then we can appreciate open source hardware as well as creativity as ways to also go into the realm of the global north. I appreciate Trend in Africa for being the source of inspiration, and also all of these various organizations, Professor Tom Baden, Dr. Luthia, Dr. Andre himself, and many other organizations. So without forgetting to appreciate all of my students, mentees, and alumni of the Neurophysiotherapy Research Lab in Olabisi Onabanjo University. They really have made all of these efforts possible, all of these interventions possible. I'm proud of them all. And I thank you all for listening. Thank you, Dr. Issa Binawa, and thank you, everybody. Bye.
Okay, thank you so much, Dr. Rehan, for very, very interesting presentation. I think I will go directly to the questions before we are running out of time. There is one already posted by one of the participants, Ahmed Salisu. If it's Dr. Ahmed Salisu from UMU, he's a chemist, so I can understand why he's asking the question. He said, "Hi, Doctor, I would like to know the source of the raw materials for the 3D printing. It will be very interesting if they are sourced from the recycled polymer. Thanks." So I think, Dr. Rehan and Dr. Andre, you can add something after Dr. Rehan. Dr. Rehan?
All right. Yeah, so they are generally, so there are different materials used. They are depending on the kind of, what's your perception of your end product is. Are you fine with a plastic-based material? Are you fine with a wood-like material? Do you prefer something metal? These are the things that determine your choice of printer as well as the choice of filament. So the printer runs on filaments, and the filament itself comes in different kinds. And all of them are, they are this rush compatible. They are biodegradable, and they are things that are well compatible with the body, with the skin. So depending on what you need them for and what texture you want your material to be like. So the printers are, the filaments from which these materials are made are very safe. Secondly, there is this increasing effort to also have filaments made out of waste, right? They are made out of waste and then, recycled. So this also will end up reducing the cost of printers and also the cost of filaments. And generally, it goes down to reduce the cost of printing. So it's also good to know that today in Nigeria, we have a number of bodies that have picked up interest and are doing well in providing materials for 3D printing, in providing 3D printing services, and also providing the printers. We also have locally made printers in Nigeria as of today. So it's really an increasingly growing community, and it's something that will be nice for every interested person to look into. I hope that addresses the question a bit.
Okay, Dr. Andre, do you want to add something?
Yeah, so I typed an answer because I also shared some links, but Hoya is absolutely right. In the space of plastics, we do have a lot of plastics that are used to printing that are derived from plants. And although they are biodegradable, they still take a long time to degrade. So using recycled materials is definitely a good idea. And I shared on the answers a link to a small discussion that we recently had online about different projects that are just recycling plastic in general to transform it into other things, but then specific projects that take plastic bottles or whatever and transform that into filament for the printers. So, okay. Yeah.
Thank you. Okay, before I go to the next question, which I would like to ask Kaisan, there is Oluwatosin who joined from YouTube. He mentioned, I think he was trying to also, because I remember Dr. Kaisan, you said that it was not exhaustive list for the universities that contributed. So he just wants to maybe you to acknowledge that University of Lagos also developed a software that they use to track infections, live tracking of infections, and they also did develop some ventilators. I think Dr. Ketan has specifically mentioned that it wasn't an exhaustive list. There are other scientists from all over Nigeria who were doing doing during the pandemic. So I think I would like to ask you the next question, Dr. Ketan. I know that you have done something during the pandemic. What I would like to know is, do you have other projects you are working on now? If yes, what are those projects? How far are you in those projects? If not, what is the major hurdles? I think you already mentioned some hurdles, but I just want to know, I'm curious, what are you working on now, and what do you think is the process?
Thank you so much for giving the floor once again. There are so many ongoing projects and some that are about to be concluded. One of them is the effluent management system in Nigerian oil and gas industry, which we designed, patented, fabricated, and tested, and is now undergoing commercialization state between Ahmadu Bello University and Department of Petroleum Resources, that is the NDPR. This project was funded by a research grant from Royal Academy of Engineering, and it was a 6-month grant. That grant was over, everything is over, but post-grant, we are working towards commercializing in the loop oil blending plants of oil and gas industries. There are other designs too that are about to be produced. Some we have prototype. For instance, we have a local pressing iron developed by one of my colleagues, Engineer Mukhtar, which uses gas, methane gas, that is normal cooking gas for iron. That is to be deployed to rural area. And the control system is solar. So no need of falling trees for charcoal. And it does not depend on what you call it, national grids. We also have a developed, paddy drying system with rake for mixture, continuous mixture, and the prototype is ready. There are so many of them, but to mention but a few, I believe there are so many prototypes under fabrication. Some are ready and some are undergoing patent registration. Within the agency, we have so many other products at the scene, but that is for now confidential because it's a government agency. Others because they have to do with university research, so we don't have that confidentiality clause.
Okay, thank you very much. I think I'll go back to Dr. Andre. When you came, I know that you tried to teach us some coding. So I believe that coding is indispensable to fully utilizing the idea of open source initiatives. So I just want to ask, what level of expertise on coding does one need to fully grasp the idea of what open source initiatives are really about?
So that's an interesting question, right? Because, for instance, I myself, I'm a biologist by training, so all of these are things that I picked up on a project-based manner, right? Meaning, whenever I had a problem in a project that I needed to conclude, I basically, like learn the basic and the minimum skills I needed to like do the next step and do the next step and so on. So rather than thinking about what are the minimum skills that people need, I think like the most appropriate thing for people to think about is like, where do I find a project that I want to reproduce, who I can contact, and where do they point me into the right direction, right? Because learning coding is fantastic and it's a very good way. Like if you want to sit down and just learn coding, right? But that shouldn't stop you from actually trying your hands on things just because you don't think you have a certain level. Of course it helps, right? But it's not a mandatory thing. So the more you know, the better. But even if you don't know any coding, right, you could learn as you go and as you move into the projects, right? I hope that answers your question.
Yeah, I think it does. So for participants who want to ask questions, you can always indicate by raising your hand, then I'll allow you to answer, although we are running out of time. Dr. Royhan, are you there?
Yes, I am.
Okay. I think recently, especially for people who are going on YouTube, you will see that 3D printing is becoming a household name. It's no longer something complex. Like a lot of people have it at home, printing weird stuff that are actually for personal use. I see somebody printing masks just like a scary mask to scare people. So it appears like in the developed world, so in the global north, 3D printing is no longer a big deal. So why do you think Nigerian youth are still not like really into 3D printing? And it's not about them not being in technology, because I know they are really into cryptocurrency, which also is very, I think it's a bit complex as well. So what do you think is happening here? Why do you think is the problem that Nigerian youth are not embracing 3D printing as they should?
So permit me to answer the question with, I think it's an interplay of two main factors. First is the unawareness, or the low level of awareness. And the second is the, let's say, the interest or the mindset. So if you compare with things like cryptocurrency, this is something that you can easily figure out how that benefits whoever goes into it, right? So you can easily figure out perhaps the entrepreneurship concept of that. So it's easy to see how that adds to your bank account, But if you do not have that conscious intent to solve the communal problems, or to provide some services to create ways out of some long-standing problems, you probably wouldn't be thinking of considering open hardware or 3D printing. And incidentally, however, 3D printing is also, like I mentioned earlier, it has some appreciable, depending on how you take it. So it has some appreciable entrepreneurial concept or potentials. So it goes back to the first point of awareness, the level of awareness. Perhaps not many people know how much it's portends, how well it can come in handy to solving a lot of problems. There are so many, spare parts of things, different equipment that the 3D printing would easily come in to fill in that hole, that gap, to keep that device running. And it also comes to build something from the scratch, things that you probably find difficult to procure elsewhere. So it's the level of awareness and the interest really to solve societal problem. I hope that summarizes what I consider the problem to be.
Yeah, very well, really. Dr. Kaitan, I need for as a final, maybe because we're running out of time, what advice do you have for researchers and entrepreneurs on relying on local content to solve their infrastructural needs?
Could you please take the question again?
So I just want you to advise researchers and entrepreneurs on relying on local content to solve their infrastructural needs.
Yeah, it is generally believed by most of the Nigerians that our people or our scientists or engineers are locally based and they don't have mindset to produce state-of-the-art equipment. This I stand to challenge. It's only that people don't look in depth. When you have a problem, you may be taking a problem as an industry, for instance, or micro, small, or medium scale enterprise to another country, let's say China or any other part of the Western world. And you may be surprised that the scientist or engineer that will be incurred to solve the problem may be an African or even a Nigerian. So when you have an issue, for instance, we have government agencies like NYA. Our slogan is ask us first. Ask us first. Before you proceed to any country to look for anything, ask us whether there is any company or industry within Nigeria that produces such a device. So if there is, we can easily link you up because we are handling technology transfers with different countries and we have records of who can do what at which place and what material time. So I believe Nigerians are good and they are capable, and with little push, they can do wonders in terms of science, technology, and innovation. So, and it's also cheaper because there is no capital flight. When you transact with your brother or sister within the same country, you transact in the same currency, there is no exchange issue. And you see the cost of production becomes cheaper and the profit is maximized. So I believe by looking inwards will solve our problems in our own way and at a much affordable cost.
Okay, thank you very much. And I think this will be our final question. Dr. Andre, you can answer, then Dr. Rehan can add something on it. And how can I apply 3D printing for teaching, for my teaching? Like, a lot of us are lecturers, and I know that probably just an advert. How do I apply this concept of 3D printing in our teaching universities? So to maybe take it, then Rohan can conclude on that.
Well, it really, I mean, you can teach, like, if you have a printer available, you could bring this in and show, like, we do practicals here with a printer as well for both bachelor's and master's students, right? And we show them how it works, and we get them to do like digital design on their own, because there is a lot of software that allows them to start right away with just like clicking and pointing at things. Of course, we want them later to actually properly learn how to design and make things, but this is like a very good way of getting them to, you know, like get their hands and experience with the technology. And then we also propose little tests or little projects, right? Something that they want to build for part of their research, or something that they need in the lab, something that could actually be 3D printed, which also opens up the very good discussion is, can I 3D print everything? Or are there things that I should not print? Should I try to source it some other way, and so on and so on. Right, I think this is how mostly we do it here. It's like project-based and getting them to get their hands on it as soon as possible, basically.
Okay, Dr. Rehan.
So I agree totally. I think it's been succinctly put by Dr. Andre. It's a project-based, approach. Depending on what is being taught, it's always nice if a 3D printer is available. So always employ it as a way of illustrating, what can be those things that you can find a way around it through the intervention of the 3D printer. Depending on what kind of project that is being taught at that moment. So, and right now at the lab too, we are at the verge of, employing this same concept in the design of a startle chamber, for rodents, to be able to, as a way of confirming, the presence of psychotic tendencies or modeling. So it's really something that is project-based, and we just shouldn't leave it out that way. To always keep it in mind will always help to help find it useful in whatever project that we have intended to teach the students. Thank you.
Okay, so I think we run out of time. I believe that the participants will agree with me that we had a very, very informative session. I know that not a lot of us, I know that when I first heard of this open source initiative and what I can do with it, I got really, really excited, because then now things that I believe that are not possible, just suddenly I can see how I can achieve them with the resources I have. So I believe that this ignites some part of you that from now on you start thinking about solving your own problem without having to wait until your university or your department buys something for you. You can always see how you can build your own. And there is also always the opportunity to collaborate. This is one of the most important things, because remember, the people that are producing these things also have projects, so they want the credit. And if you have a problem and you bring it and you solve it together, this is a collaborative project. So don't always think about how much you're going to spend alone. You can always approach people that are already doing it and see how you can collaborate with them and produce something that you specifically need. Because actually there is an investment opportunity in this. So it's not only about you spending, you can actually get something out of it. So I would like to thank our speakers, Dr. Andre, Dr. Kaisan, Dr. Rehan. We are very, very grateful for honoring our invitation. And I hope that in the future, when we approach you again, you are going to join us again to give us more of this exciting. And probably in the next time, we are going to go into more in-depth and technical aspects of the topic that we discussed today. And I would like to thank the Nigerian Academy for organizing the webinar, and then of course, the sponsors of the webinar series on COVID-19 under the Africa Rapid Grant. This is the 8th webinar we have this year, and we have about two more to go. Yeah, so I hope that the participants will join us in our future webinars, and we really appreciate you for making it possible. Without the participation, I don't think what we are doing would make much sense. So thank you very much for joining us, and see you next time.
Thank you, everyone. Bye-bye.
Thank you for the opportunity.
Thank you so much.